Alrighty, so let's look at some example problems. Okay, imagine that 4 children want to share 4 brownies so that each child gets the same amount. All of the brownies must be handed out. How much can each child get? So if I were you, I would grab 4 Post-its and imagine that they are brownies. Okay, you could even draw your 4 children. We'll pass out the brownies so that they each get the same amount. If I were to pass it out, I would say you get one, you get one, you get one, and you get one. So each child gets 1 brownie. Each child gets 1 brownie. Let's think of another problem. Clean up my brownies. And let's say that 3 children want to share 6 brownies so that each child gets the same amount. All of the brownies must be handed out. How much can each child get? This time, I want you to use 6 Post-it notes to help you with this problem. Draw your 3 children and pass out your 6 brownies. If you were to do that, each child would get 2 brownies. Each child would get 2 brownies. Let's look at our next problem. Two children want to share 3 brownies so that each child gets the same amount. All of the brownies must be handed out. How much can each child get? How much can each child get? 2 children, 3 brownies. Again, you can use 3 Post-it notes if you'd like. You might have to manipulate those Post-it notes a little bit to equally share with those 2 children. Well, each child is going to get a whole brownie, and each child is going to get half of a brownie in order for them to have the same amount. Here's one way we can split that up, or we could take some brownies and we could say, okay, 1 kid's amount is here, 1 kid's amount is here. If we cut each one up, 1 kid, second kid, first kid, second kid, first kid, second kid, these 2 halves would combine and make 1 whole, and then I'd still be left with a half. So each child would still get 1.5 brownies. Let's continue. Suppose you have 2 children this time and they want to share 1 brownie. How much would each child get if they want the same amount? 2 children want to share 1 brownie so that each child gets the same amount. All of the brownies must be handed out. How much can each child get? Again, this time I would use 1 Post-it to represent your brownie, manipulate it so that each of the 2 children get the same amount. Well, each of the 2 children are going to end up with half of a brownie. Each of the 2 children are going to end up with half of a brownie. Half of a brownie. We take that 1 brownie and we split it up between the 2 children. So today, in this lesson, we're going to be discussing the relationship between equal sharing and fraction, equal or fair sharing and fractions. I love fractions. Some people are a little scared of fractions, but I think fractions are fun. Today we're kind of going to look at a couple of different ways to view fractions. So the first way that we're going to look at fractions is the typical way of looking at it. Here are fractions 3/4. If I had a pizza, 3 out of 4 pieces would be that fraction. Here's again a piece of pizza, 5 pieces to make one whole pizza, but I only have 3 out of the 5 pieces. The 3 is my numerator. It was cropped off a little bit. And the 4 is my denominator. The 4 is my denominator. Vocabulary words that we need to know: numerator, top number, denominator, bottom number. This way that you've probably learned about fractions. The bottom number tells me how many pieces make up the whole, and my top number tells me how many I have, how many parts I have. So in this problem, that was a kind of part-whole way of looking at it. Always, this way of looking at it is always in regards to one whole pizza. And so this one we're going to say commonly referred to as part of a whole. So again, this is with one whole that we're talking about. Okay, so for example, Sarah ate 3 pieces out of 4. So maybe that pizza is split into 4 pieces and she ate 3 of them. This is a great way to view fractions, and that's definitely the most common way. But what if instead of having just 1 pizza, we had 2 pizzas or 3 pizzas? How would that problem change at that point? Well, let's look at something a little different for a second, something maybe a little familiar to us. What are we doing when we divide 8 by 2? Well, if I divide 8 by 2, I'm going to make 2 groups. Here's 1 group. Here's 2 groups. And I can fair share or give equally to a set number of groups. So if I have 8, let's say 8 little circles, I'm just going to share equally, fair share, and go until I reach 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 divided by 2 gives me 1, 2, 3, 4. 8 divided by 2. I split 8 up into 2 groups. So I'm fair sharing or giving equally to a set number, which in this case was 2 groups. Let's now look at 12 divided by 6. Well, that means I'm going to want 1, 2, 3, 4, 5, 6. 6 groups. And I'm going to, again, fair share or give equally to those 6 groups until I reach the total of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oop, I'm there. 12 divided by 6 we know is 2. So I was able to fair share or give equally to 6 groups, getting 2 as my answer. Well, let's continue onward to 10 by 5, dividing 10 by 5. Here, we said, okay, I have 2 groups. Let's split that up into 2 groups. Here, I said I have 6 groups. Let's split it up into 6 groups. What if this time instead, I told you the amount in each group? So here I have 10 and I'm making groups of 5. So I'm going to do 1, 2, 3, 4, 5 in a group. I'm going to do another 5, 1, 2, 3, 4, 5 in a group, which gives me a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divided by 5, that still gives me an answer of 2, but this time we're asking a different question. Here, we were saying how many go into each group. Here I'm saying there are 5 in each group. How many groups can I make? Different question. The division is the same, but what I'm looking for is a little different. I can make groups of 5 from 10. I can make groups of 5 from 10. So let's look at our second way of viewing fractions. Our second way of viewing fractions, which is a fair share division problem. A fair share division problem. Last way I want us to look at a math problem, a fractional problem. So we have part of a whole dealing with one whole. Here our whole changed. Here our whole changed. And just to give you some background on that, just a little bit of background on that, looking here, we can also write this in a different way. We can also write this in a different way, but we'll get to that in a second. Here's another problem I want us to take a look at. 2 children want to share 1 brownie so that each child gets the same amount. All of the brownie must be handed out. How much can each child get? Well, this is a problem we looked at earlier. What division are we doing in this problem? We were just talking about division, and here's a division problem because I'm dividing or splitting something up. Well, the answer that we got, each child will get 1/2 of the brownie. Well, what are we sharing? What division are we doing? Well, I'm taking that 1 brownie and I'm dividing that 1 brownie into 2 groups. That 1 brownie into 2 groups. Well, I'm confused a little bit, guys. That 1/2, is that the answer or is that the problem? Well, here it's both. Both the answer and the problem. If we go back to the last part, here 12/6, if I change that from an improper fraction, it gives me 2. 10/5, if I change that from an improper fraction, oops, gives me 2. 8 halves gives me 4. So not only is this the problem, but it's also the answer. So here, for number 3, a fraction can also be a quotient, which is the answer to a division problem. So here, Sarah ate 3 pieces out of 4, part and whole. The 4 represents the 1 whole. The 3 is how many she ate. A fair share division problem. If Stan's family had 3 candy bars and shared them equally with 4 people, he would pass them out and divide them. And that would be my problem. And here is an answer. Stan's share would be 3/4 of a candy bar. This symbol here, which we use in fractions, is also a division symbol. Not only is this the answer, but it's also the division problem. This is how I would write the division problem, but I already know that this can be written as a fraction. Let's apply that to something that we're familiar with. Change improper fractions into mixed numbers. Here, 5 halves. If I have 5, 1, 2, 3, 4, 5 brownies, and I split it in half, here I have 1 whole, 2 wholes, and 2 1/2. Well, 2 1/2, yes, is equal to 5 halves, but one way I can figure that out is seeing it as 5 divided by 2. 5 divided by 2. 5 divided by 2, I'm going to divide, which gives me 2. Going to multiply, gives me 4. Subtract, gives me 1. And I have nothing to bring down. If you recall, when we write mixed numbers from improper fractions, the whole number of groups I can make becomes my whole, my remainder becomes my numerator, and my denominator is what I'm dividing by, because I'm still dividing 1 by 2. I'm still trying to divide that by this 1 into 2 groups. Still trying to divide this 1 brownie into 2 groups. Let's continue to get some more practice, reminding ourselves how to convert and change improper fractions into mixed numbers. This can be read, it could be my answer, but this can be read as 9 divided by 7. Well, I could tell you that 9 divided by 7 is 9/7, but they want me to change it to a mixed number. 9 divided by 7 is 1. Multiply, 1 times 7 is 7. Subtract, we get 2. I was able to make one whole group of 7 from 9. So this gives me a whole number of 1. I am still trying to divide that 2 by 7. Continuing on, here this problem means 11 divided by 6. 11 divided by 6, I cannot divide the 1 by 6, so I'm going to move on to 11. 11 divided by 6 is 1. And I'm left with 5. I was able to make one whole group, and I'm still trying to divide 5 by 6. 18 sevenths is the same as 18 divided by 7. I can't make any groups of 7 from 1. I can make 2 groups of 7 from 18. And I'm still going to try to divide that 4 by 7. still going to try to divide that 4 by 7. Let's move on to more problems in our notes and some maybe easier ways for us to remember different ways that fractions work. 2 bags of bird seed are used to fill 3 bird feeders. How much bird seed does each feeder use? Represent the situation using the model, then solve. Okay, so 2 bags of bird seed. So this is 1 bag of bird seed, a second bag of bird seed, and I'm going to split that up among 3 bird feeders. So this is the first bird feeder, the second bird feeder, and the third bird feeder. Okay, well, if I do that, this was 1 bag, so this is 1/3, this is 1/3, and this is 1/3 of that 1 bag. This is 1/3, 1/3, and 1/3 of that second bag. How much does each bird feeder get of the bag? Well, the first bird feeder gets 1/3 of a bag from this bag, and 1/3 of the bag from this bag. Well, 1/3 plus 1/3 gives me 2/3. That's one way to figure this out. It's a longer way than necessary. If we use this method and a different way of looking at fractions, we might come to our answer a little quicker. So I'd like to think about what I'm sharing. What am I splitting up? Well, I'm going to be splitting up 2 bags of birdseed. And I'm going to be splitting it up into how many groups? I'm going to pass it out. How many groups am I passing it out to? Well, I'm passing it out to 3 bird feeders. So I'm going to write 3 bird feeders. So this problem is 2 divided by 3. Well, 2 divided by 3 can also look like this. Well, but that right there, that's an answer. 2/3. And that's the same answer that I got over here. Each bird feeder uses 2/3 a bag of birdseed. Again, not only is it the problem, but it's also my quotient. It's also my answer. I'm not going to use this part of a whole idea because I have more than 1 whole. I have 2 bags and I'm splitting it up into 3. Here's the proof of how not only that's the problem, but it's also my answer. Let's look at this last problem. There are 11 yards of ribbon for 4 people to share. How many yards of ribbon can each person get if they share